Find the change in pressure between points F and A in pascals. In this problem, a manometer contains 5 different fluids, which include benzene, mercury, kerosene, water, and air. The vertical distance between adjacent liquid interfaces is either given or can be calculated from the given distances. Points A and F are located at the two ends of the manometer, and the temperature is 20 degrees Celsius. The problem asks for delta P of AF, which is the same as the pressure at point F minus the pressure at point A. This pressure difference can be computed using the general equation for the change in pressure across a fluid medium. Delta P equals negative rho G delta H, where delta P equals the change in pressure, rho is the density of the fluid, G is the gravitational acceleration constant, and delta H is the change in height in the fluid between the 2 points whose pressure difference is being calculated. This equation is only valid if the density is constant. If we want to find the pressure difference between 2 points which are separated by multiple fluids having different densities, then we must compute the pressure difference for each density and sum those pressure differences together. In our problem, there are 5 different fluids in the manometer, so we'll use the second equation. For convenience sake, we'll define the points B, C, D, and E at the fluid boundaries. This makes it easier to write out our equation for delta P of AF. After expanding the summation term, we see all the density and height terms we need to determine in order to solve the problem. First of all, we know G equals 9.81 meters per second squared. Next, we'll use the figure to determine the change in heights between adjacent fluid interfaces. Height B minus height A equals negative 20 centimeters. Height C minus height B equals 8 centimeters. Height D minus height C equals 40 centimeters minus 8 centimeters, which equals 32 centimeters. Height E minus height D equals 14 centimeters minus 40 centimeters, which equals negative 26 centimeters. And we currently do not know the change in height between points F and E. Next, we'll look up the densities of these 5 fluids at standard temperature in units of grams per cubic centimeter. Then we'll multiply these values by 1,000 to convert the densities to units of kilograms per meter cubed. And after we plug these densities into their appropriate variables, we notice the density of air is so much smaller than the other densities that we can neglect this final term from the calculation. After plugging in all the variables, delta P of AF equals negative 886,824 kilograms centimeters per second squared meter squared. Next, we'll convert centimeters to meters, and then convert the units to pascals. And our final pressure difference between points F and A equals negative 8,868 pascals. When reviewing the possible solutions, the answer is A.